Nothing is exploding inside this machine. What pushes it is plain steam. That steam presses the piston with 1.9 tons of force, the weight of a car. Push out, push back, over and over. Yet the rotation never pauses, and the speed holds itself steady. The trick is inside this block of iron. We made it visible. This is a steam engine, a machine that turns powerfully on steam pressure alone. But how does a back and forth, push and pull motion become smooth, continuous rotation? And how does its speed stay steady, even when the load keeps changing? Let's look inside. There are 6 players. Steam enters the cylinder, and a piston slides back and forth inside it. The piston connects through a rod and crosshead to the connecting rod. On top sits the slide valve, the part that switches the steam's path. The reciprocation becomes rotation at the crank, and a big flywheel smooths it out. And up top, the governor, the part that watches over the engine's speed. Here is the core idea. High-pressure steam shoves the piston hard from one side. The key is this slide valve, driven off the very same crankshaft. The valve runs about 90 degrees ahead of the piston. The instant the piston reaches the end, the valve slides and switches the steam's path. Fresh steam goes to the other side, spent steam goes to exhaust. So the return stroke pushes too. The reciprocation becomes rotation at the crank, and the flywheel carries it across the gaps. In physics, the work the steam does is the area of the pressure-volume loop. The area of this loop is the work per revolution. This is the famous indicator diagram. The force on the piston is pressure times area. Higher pressure pushes harder. That force twists the crank into torque. Steam acts on both sides, so both strokes drive. The governor guards the speed. Faster, the balls fly out and close the throttle. Now let's load the engine down hard. The speed dips. The balls drop, and the throttle opens. More steam restores the torque, and the speed is pulled back up. Faster closes it, slower opens it. This negative feedback holds the speed steady. This power to hold its own speed drove the Industrial Revolution. It could turn a factory's machines, all day, at a steady speed. The steam engine was the self-regulating prime mover that moved the world. NovaSolver. Physics made visible.